This looks good, but if it has leaking problems, I can see water damage in there, and because the only thing that's stopping it from leaking is this caulking. And I can see that there's some cracks in it already, like right there, for example. Your building, you're not talking about this one, talking about the shelter, talking about you have grades around your building. The bigger the building gets, and you'll see this in a lot of like even this one here, and the big one here, this one here. You'll see like you have at some point you have to choose where's that main level going to be, what height, and then what you have to do is you go around your building, you find every door leaving your building, and then you figure out what's that grade outside. So if you look right here, you know there's a bit of a gradual slope up to the main level right there. Go over here, we're gonna walk by this. There's a whole bunch of stairs. On the other side, there's even more stairs, and so on and so forth. So really, what the process is to get all your doors in place, and just go around and pick your grades, see what they are, and then figure out a solution. So on the inside, you can certainly slope doors and stuff. Just stairs on the inside, but usually it's on the outside where you find it. That's good. Yes, these ones here are called impact resistant. So you run into them like this. So those are smart signs.
And this, and then the painting.
Yeah, this doesn't actually need curb control. It's freestyle, but.
And here's you know how we're sloping our parking lot.
Yeah, so this is a catch basin, and you can just see like they just taken pretty much a rectangle here, and then just slope from each point. Catch basin. That's what they've done here. And let's just walk down a little bit farther and see what they've done over here. Because as you can see, the grade starts dropping pretty drastically. We can talk about this too.
Yeah, talk about the rest.
Anybody knows the solution to this, so this doesn't happen? Now this is really old, but this can start to happen. Once you don't do something to the metal. Everybody know? You do the metal. You don't want it to rust. Galvanize it, yeah, you'll see. We'll find some actually probably somewhere, but you can do it with steel. So in this case, inside the paint, it works. Rust. So, you know, that's obviously what's happening here. That starts to rust. That's very hard to paint. Get it totally sealed, right? So if you just take the metal and you dip it in a zinc bath, it's literally like a silvery liquid. If you just Google it, you'll see like the process with a big bathtub full of zinc melted basically, and then you have steel. And when it comes out, it's got a finish that won't rust, basically. Galvanized. So any outdoor steel I always love. Always. No matter what. That's good. This is what you're looking at. The other option is stainless steel as well, but it will rust over time a little bit. It's certainly better.
Okay, this parking lot is a bit of a challenge for drainage.
So here's an example. You know, we have traffic grades, and you can't put a parking stall on more than a 4% slope. So they didn't put a parking stall here. So what they did was to make up the grade. They said, let's do a landscaping strip right here, do a steep slope, and then get down to a less, 2% slope. So that's one strategy you'll see a lot. Instead of just doing a retaining wall, if you can just get a little bit of landscaping, then there's no parking on that spot. So that grade on that ramp right there could be like 8%, 10%, like whatever you want, really. And then when you get down to the bottom, now you have a lot of ground, get down lower, and then you just do like the catch basin idea again, where you do a triangle, catch basin in the middle. So that's a strategy that's used quite a bit. And then look for things like this, right? And start to figure out, do I need stairs? Do I need ramps? This is quite old. It's a good approach. It's an automotive scientific design is actually with garage doors. All these fronts are supposed to look like a garage door. Yeah. There is problems. It's that big thing at the top right there. Again, that's just built up with probably there's probably some thin steel in there coming off the main structure, but it's not really tiny enough. It's just dead space inside there. It does have a problem in the winter time. If you're here next semester, pay attention, but you'll see icicles behind that. So water's just kind of running down the front face of it, and then it goes back like this and starts to drip, and it turns into big icicles. That type of stuff is not always easy to predict when it's going to happen, but it's certainly something we always consider. If you just walk downtown and you see the signs, caution, falling ice, You know, and you got like a 30-story building, it's like, okay, well, what am I supposed to do? You know, you're going to kill you. So, one big photos. And I can show you what this part is. But basically, all it is a stucco on there. So they cut on the stucco and get into the insulation. They got a nice cozy home in there. So there's a whole bunch of them there.
What do you
There's
reckon?
one on the other side of the other building where I posted it in the photos channel where, or no, a water cooler, where the birds out there have eat me when I'm going home. It's like, they're so happy.
Where is it? Where's the bird's nest?
These holes.
Oh.
That's why there's bird poop around it.
Oh yeah.
Yeah.
Cute. Her head's in there.
You're right.
Maybe it'll go.
Maybe I'll go to work.
There's some open wood steel joints right there.
Yeah, this one's actually pretty good here.
Oh,
We're going to go in. Well, we will go in our buildings actually.
I guess.
This is our new reality.
Here's some T-bar ceiling.
Yeah, there's a few
We're gonna draw that in a couple days.
Look up right there, and what you're seeing is a steel beam along here, okay? And there's a steel column right here behind this concrete block. Anybody know what's going on? What is that stuff? Not spray foam, no. What might you want to put on a steel beam, you know, a larger building like this? It might have to be fire protected, right? So a lot of you might end up putting that stuff on your steel in the building. We don't know yet. We'll look at that next week. We'll know for sure, I think probably Monday or Tuesday next week. But that is a very common way to fire protect steel. You put this, it's a cementitious spray that goes on there, and it goes on the beams, on the joists, on the metal deck, and that gives it the fire rating you need. So if you need 1 hour, they do a certain thickness of spray. If you need 2 hours, it's thicker, and so on and so forth. So it's used quite a lot in steel buildings. The downfall of it is, if you look around, like I was at a gym in North Hill Mall, the basement, whatever gym it is, and people are picking this stuff off, right? So that's kind of the problem with it. So like in a case like this is why they encased it in this, so that people are going to be picking that stuff off, for example. So, but very, very common. You'll see that as you look around. And as we go past this room here, you'll see your open up steel joist, you'll see a steel beam.
Open up right there.
This one's really good right here. Just take a peek in here. So this is what's called a mezzanine. So obviously in this case, the mezzanine didn't have to be fire rated because it's not part of the main floor structure. But you'll see a beam on the edge here, and you'll see your open up steel joist. That's essentially what you're doing in your building. Just take a peek in there as you go by.
Oops, sorry. Oh, sorry. Here's some signage.
Here's some cross bracing. We haven't got into this yet, but this bracing here, so it goes up to the beam right there. So it attaches to the beam, comes down here and down there, and attaches to the column in here. This is what prevents the building, like once you put the sticks up, when the wind blows on the building, it wants to go fall over. So this is the bracing that prevents it from just going.
We didn't draw
We're
that.
going to deal with that later yet. We're not going to draw it in, but we'll just find locations for it. I'll give you some rules of thumb. Anything in there that's interesting? Oh yeah, look at that. They got giant. Oh, that's weird. That's really weird. They got some giant trusses, and only 2 of them are fire rated. That's not normal. Usually they all have the fire rated.
I think. Let's go in the stairwell.
That's it.
Yep. We'll all jam in there.
Yeah.
Oh, this is open riser. This one. This one has open risers.
Yeah, so. Yeah, this is a pretty common steel stair situation. This one has an open riser, obviously, so usually there's a piece of steel here as well. Yeah, this is obviously more of a feature stair than an exit stair. So, but yeah, this is the pan. So when we talk about the concrete filled pan, there's just a bent piece of metal that's U-shaped right here, and then it's filled with concrete. That's pretty much all it is. You see channels on the 2 sides, and those are your stringers. So that's the replacement of the what is it, 2x12 you guys used for your stairs last year? We just use a C-channel instead. And the nice thing about the C-channel steel stairs is post can attach to the top of this. And then you don't have that big gap here, which we'll look at actually on the center of the issue all concrete stairs.
There's your flat bit at the bottom. This.
Oh yeah, the extension at the end, 300 on the end. This is an older building. The code might have been a little bit different when this was built. But yeah, there's their landing right here.
A landing with C channels, I think.
This is a metal deck, and the concrete on top of that metal deck. Silver sunset. This is a curtain wall right there. Curtain wall system. We're going to see lots of that as we go. Notice how they didn't delete the main second floor structure right there. They kept it in there. Usually that's the case. We're going to look at a better example of that though, going forward. Okay, let's go down this thing.
Oh, that's.
So for those of you with a an overhead door maybe for your garbage room or something like that, so a big garage door, this is how you finish off, whether it's interior or exterior, this is how you finish off the end. It's always a bent piece of metal, just like that, almost like a C-channel, but it's just custom bent to suit your wall thickness, and you always turn out like that.
Vestibule.
Talk about the vestibule. There's a good thing in the T-bar.
Oh, yeah.
So some of you will probably put T-bar in your corridors,
Or off.
maybe, or in your lobby, maybe. But here's a good look at it right here. What this is, it's a really lightweight aluminum track that just gets hung from the structure above, and then you just put these. There's different types of panels you just lay into the basically very, very common, cheap commercial ceiling system. So that's a good view of it right there. When you walk by, take a look at that. Notice the exit sign.
This is a vestibule and the doors are opening out. Just look at the vestibule.
Yeah, vestibule. This is so you usually find these inside. That's the heating unit for the vestibule, basically. Usually vestibules have that.
Oh, there's an angle for the brick up there.
Yeah, so we're gonna look at some more brick on a different building, but this is called a soldier course. Okay, so when again, this is like people that were like, can we just swing that door open? We'll look at more brick later, but for people that have brick on their building and they're like, well, I want more design in my building, you can do a lot with brick. So for example, that's called a soldier course. You don't have to do that right above an opening, but that's a very, very traditional, common way to do brick above an opening. Basically, you turn the brick up, and one of these bricks equals 3 of those bricks. See that? And that's what you work with as you start to design the facade.
And there's an angle.
And here's the angle. Now this is a piece of steel that's shaped like an L. That's supporting the brick. Okay, so this angle just spans across into here, and the loads come down there, and then down right here.
There's your wall-mounted handrail.
Yeah, it's pretty much the same type of stair. Okay.
That Revit likes to draw straight, not attached to the
We're
stair.
not even open these doors?
Oh, maybe we can.
No, it's gotta be.
No.
Press the button.
Oh. Amazing.
No, I worked in like everybody. Okay, this one.
Anyways, there's an example of a strip of curtain wall in the stairs, like some of you might want to get some light into your stairs.
There's some letters on the building we talked about yesterday.
Okay, let's go across this way.
Yeah, so here's a nice, this stair empties into the vestibule. Yeah.
Anyways, there's a stair in behind there as well. So if you look closer, you'll see that's an exit stair right there. So they've done the whole exterior with curtain wall basically, and then you go through the vestibule and then out to this place right there. This canopy, we're going to talk about a very similar canopy on this building. But one very common problem with these canopies. Come. Right? When you build a canopy, you gotta touch water. You gotta put water somewhere. It's always overlooked. So now when you walk around town, anywhere you go, you're going to see these pipes sticking out of town. What it looks like. They have to find solutions to it.
How about this cladding? What's that?
Yeah, this is clay. So this is I was showing pictures of the music center.
Yeah.
Clay tiles going very vertically. It's kind of the same system. It's clay tiles. And these tiles are just hanging off a subsystem basically. It's the tile manufacturer subsystem. Then that system attaches to our typical rail system that goes through that. I don't know what it's called. I don't know who makes that one.
You have to have handrails every.
Oh, that's a good point. So again, actually this is a good example here of how they're built building. As you walk down this way, you'll see that they decided to set the main floor elevation based on some grades halfway up this road. By the time you turn it around the building, like we're not even far from it, all of a sudden we've got like going to notice the railings, like so the code will tell you have to have railings every so often on these stairs. I was going to point out this here. That's an SSG corner on your curtain wall. Okay, so you can do a capless system. Those are quite favorable to architects. They love that design. So just a clean, capless, structural silicone glazing system. Take a look at that if you want.
How about this?
Yeah, and actually, I'm gonna talk about this. That's stadium. Over here, though. So notice the grades here coming up this building. And so again, there's a door right in the middle here. That's where they've set this main floor elevation of this building. Now, what's important when you do your elevation, you got to be true to the grades because if you weren't true to the grades, one, you wouldn't know about the stairs, but you also wouldn't realize you wouldn't buy that much. Right? All the way across, but all of a sudden on site, the contractor would be like, hey, I have to buy like double the amount of granite to show that's a change is. So you always want to catch these things. Like that, figure these things out so that the proper amount of granite is purchased.
This is on a slope.
Yeah, so this here, I want to talk about that down here. There's another better. See this right here? See that staining right there? That's because the sealant they put on here wasn't compatible to the stone. So that'll stain, you can't wash that out. So basically the stone is porous and whatever's in that caulking there is leaching into the stone. The only way to fix it is to replace the stone. So there are sealants that are compatible with that. You just gotta do a little bit of homework. I wouldn't know myself, that's kind of spec writer stuff. So if you're into spec writing, they would really dig into what's the right sealant, what's gonna be compatible with that stone. You would just on your drawing say, sealant. But the specs would then say exactly what that sealant is, so you don't get that situation. Who had a law for class last semester? So see this? So this is good. They sloped this away from the building. The sills slope. And you're getting staining all down here. What can you do to prevent that? Because this gets dirty, right? It's a horizontal surface pretty much. So you hot dirt, it rains, and the dirt washes down. The other day you stain all your sod. How do you fix that? There's one little detail they could have done here that would have prevented all this staining down here.
Flashing?
Well, you don't want flashing in this case because they want to see the stone. But yes, you can do flashing, but what though? The flashing gives you something on the edge.
Yeah.
Drip edge, I think I heard it. You gotta have a drip edge. So what they could have done here, instead of the flashing, they could have just extended this top stone out. About that much. All I would have to do, extend it out, and then the water would not be on the surface right. Those are the misses in nice buildings. It's a nice building, and it's too bad that there's little things like that that have been done.
Here they've done a strip of windows to show the column. See that there's a concrete column in here?
So they've actually taken kind of the opposite approach of the normal. Normally you hide the column, you get solid wall. In this case they say, no, let's show the columns. That's kind of cool. People will never notice that. You know, things like this bother me. So they've done a nice job laying out the Nickelbaum panel here. So that's a Nickelbaum, the silver stuff. And so they put it on the soffit as well. And they got like the joints obviously, so they do your ceiling tiles and show the joint for their door. But what I don't like is when the lights are centered because it just drives me crazy. Ugh. It's like I would have put a light there, there. That's just me, right? Was it overlooked? Maybe. Or maybe somebody just thought that looked good. It does to someone. You really want to pay attention to details of buildings. But check this out too. Custom caps. This is a normal cap on a certain wall. Okay? They've got a custom way to do it. A little bit of interesting. Okay. Yeah, see, this is it. Essentially for that. So we've got the stairs down there. Stairs down here. I think the other entrance is flat too. So that one is the start point. But when I look at this, I don't like these stairs down here. You'll see when you get to them because they kind of taper off, which is kind of dangerous.
Yeah.
And when I look at the road grades here, if they could have redone the road, but they probably could in this case, this whole hump could have been lowered down probably, right? So if this is a brand new site, we probably could have lowered everything. Then this floor would have lowered down. We probably could have got no stairs on this end, protection. Grade's fun, but it's hard.
Here's your curtain wall door that you did your curtain grids to get it in there. Now you have a new appreciation for that?
That's your Siamese connection. We talk about the Siamese connection.
We haven't yet. No, we will.
This is required for any sprinkler building, pretty much. And these are the things I think we have briefly discussed it, but it has to be, can't be closer than 3 meters to your main principal entry. They can't be more than 15 meters away. So that's why it's kind of right there in relation to this. This is obviously the principal entry, so the fire truck can come from right here. And then they can hook their hoses up to that and pump water into maybe we'll see it somewhere, into a pipe system that's in the stairwells. And then they can run up the stairs, firefighters, and they can hook their hoses up and fight the fire on the floor with the fire zone. But that's kind of the start point of that system. So you'll see that in most large buildings. You guys will have that in your building as well.
Here's some nice clad columns.
Yeah, you were just showing that the other day.
Yeah.
That's a illegal bond. It's called composite metal panel. There's many suppliers of that material.
And some.
Feel it. It's not metal. It's kind of a mix of metal and maybe plastic fiberglass or something.
Yeah.
That's called composite. It's a composite of several materials basically. And you say, Lyndsay, there's shoes with ice on this thing. That's right, actually there is.
Yeah, they usually they have the little signs.
These things. That's right.
It falls off here and hits you in the head.
So, you know, it's up above somewhere, there's a little bit of a drainage issue or whatever, but yeah, there tends to be icicles on there. But you'll see as you come around here how close they got to not having to have stairs, like tapers off, there's none on that side. So they're just going to lower this just a little bit. Probably could have gotten on this set of stairs right here. Just had a little bit on that side. Okay. Oh yes, there's something in here we gotta look at. This is a good one. Brandon's not here. Just go here, guys.
He's in Victoria.
Oh, that was faster this time.
Yeah.
That was way faster.
Yeah.
Everybody's ready now. Okay, so. Oh. By the way, that glass right there, see that glass around that opening? That's called a smoke bath hole. There might be a couple of you that might have this. If you have open it from your main floor to your second floor, for example, or maybe you look down below, you gotta put smoke baffles in, usually, and they look like that. And what that does is, if there's a fire down here, the smoke wants to rise, it's warm, right? And so it allows the smoke to rise on the main floor, but it doesn't like just all of a sudden all concentrate to the upper floor really quickly. So it allows it to build up a certain thickness on the underside of this floor, and the glass keeps it there. Eventually it'll spill over, obviously, it buys time, basically. That's called a smoke baffle. So you'll see that in all of those nuts, you see that right before opening. That's really what the purpose of that is. This here is interesting. So they have an exit stair right here. Now who watched my video, the exit stair in the other building? When you go into an exit, what has to happen? Usually. You go down the exit, you go straight outside. That didn't happen here. So they've done the clause of one exit is allowed to go to the lobby, but they didn't have a lobby, so they made a lobby right here. That's why these doors are here. Yes, just come out the exit, scoot out the door. So they, there's these little tricks you can do in design. Darren's not here, but I have a conversation with Darren. He kind of has to do the same idea. A little vestibule with the stair that has two corners. So basically, the idea is you can't come down that stair, enter back to the unsafe floor area. So, except for the one closet, one end closet with the lobby. There's the lobby. There's that connection to that Siamese connection on the outside. So I think they left it exposed here on purpose, but you'd have to remember there's a bunch of pipes coming in, so normally they close it off. I think it was done intentional here because they want to show off. Got some buildings here.
Yeah, you know how I said draw the petty map? There it is.
So here they attach this vestibule, and as we make there's a path down here. I want you to pay attention to the structure here. So we've got a column in the corner there. We've got a header across here. So maybe decided to do round steel here. We've got a column in the corner, a header right here, and see the knife plate, the piece of steel coming off the middle there, and on that head, actually one there too. That was the new counter. We're supposed to have people do that counter too.
There's the metal bars.
We're going to look at different. This is very commonly done. Okay? So basically you have this steel frame for the canopy that's provided here, put a roof on it. But if we have back the structure on the inside, what's wrong with that? We've got a big piece of steel coming from here, going straight through into there. There, and there's my ugly pipe cover. What's wrong with that? What's bad about that design? Well, the water's okay, so we've got a trough. This is a trough here, so the water goes back into the gutter. The gutter goes there. But I'm talking about from the heat loss standpoint. The heat goes through metal really well, so constant heat loss through every one of those connections. Pretty normal. Okay, pretty normal motion things, but there's canopies on the other building. You will see they purposely avoided distance so they're not far from it. What's the side lodge right there? What's that? Yeah. So this whole fancy thing right here, it's to catch the snow off that roof. Right, it's going to slide down there and start smashing people in the head. So they've actually built this huge trough section on down there. Which is made of a feature, basically. One of the mistakes in the story that I just made mistakes. So that's the exhaust from the parquet. So again, if we have fabrications for this, we have to very original one, like the 1907. So this is done in a very traditional, educational, I guess, design, which I think is kind of timeless. It will be timeless. These ones here, I suspect, will be timeless. 60 years, they're going to look. They were designed to the flair of the moment, basically, whereas this is designed to a tradition. Let's go that way.
Yes,
so
especially that
thing. A lot
thing.
of different detail and brick. In this case, it's actually not a lot of detail on brick. It's just different colors.
Yeah.
Right? Just different colors. They haven't turned bricks. They don't want to do curtain wall caps. You can do all kinds of different shapes. So these are this is actually custom too. It's about an 1.5 inches deep, and this one's like 3 inches deep. This one's got a special shape. So these are just little details that they put into this building. Brickwork. Let's see if we can find it here. Oh, let's look at this one here. See that hole? What's that for? Drainage. So we have an air cavity behind the brick, right? Rain screen system. It's the original rain screen system. The idea is that there's an air cavity behind the brick. There's a vent hole up here somewhere. We'll see it somewhere else, but there's holes up there. And then basically, if any water gets through the brick, it's a porous material, so there will be some. it can drain out right there. So those are very important. It's called a weep hole. And you'll see there's a screen in there. If that wasp don't go in there, they hold it there. Little screen. The concrete or accessory material is very, very tricky because it starts to soak up the salts and water and stuff. So we've raised that intentionally there. And this is a running bond right here where they stagger the bricks like this. You can do a stack bond, which is a more institutional one. But on straight lines, they have to put the saw pretty much and cut them in straight lines. There's control joints. So you want to determine where to go. And they've done something very smart here by lining up with the windows, because if you don't do that, oftentimes you get cracks from the corner of the windows through the brick. So by that putting the control joints right there, every single window, they'll never have an issue. Timeless. It's actually detailed really, really well, this building. You see it all up there, through the control joints.
This was Coho's.
Yeah. Yeah. I don't know what you're doing.
What are we doing?
I was going to show the shelf angle. So you'll notice just below the beige brick there's a lot bigger gap there. Okay? And so what's happening there is there's actually a steel angle there supporting that brick from that point up. When it gets lower the brick, it's too much to carry all the way down here. And eventually just crush itself. So at every floor, you usually put in a shelf angle to lower that brick. And so it is obvious. There's ways around that. But, you know, and again, you see the drain point there. Because the water's going to come down, it's going to hit that steel angle that blocks it. So you put drain hoses for every shelf angle. So we'll have details like that. And they get it 100% based on 1, 2, 3, 4, 5 bricks. So that you don't get cut bricks. So they intentionally say, okay, I know a brick is 57 millimeters, and I know a mortar joint is 10 millimeters. You work your way up. That's how you decide where your sill is on your window. Okay, let's go right here. Gypsum board. In behind there is just curved, lightweight metal, like almost like metal studs supporting all that stuff. It's maybe not construction, and gypsum boards just go on top. That's essentially what that is. Oftentimes you'll get these little ledges in there, they put lights in there. Those are called coves. They're very popular in bathrooms, turns out. And so this building here used to be, that used to be an exterior wall, this building. And that was the original building, and they built this building onto it. Very nice space. Piece of steel in there. Hold it back up.
I know it.
Come on in. Okay, so here, you can see we have, what is this, 1, 2, 3 floors, 4 floors pretty much, 3 or 4 floors of curtain wall here. But notice the structure, okay? So take a look at the aluminum frames, and then notice that they've kept, at every floor level, they've kept in this steel structure. So it still has the curtain wall that hangs off the structure. It can span multiple floors, but it's very, very, very seldom done. Because you can add steel to the back section of the curtain wall. Usually what happens is the curtain wall goes in, when you have a big open space like that, you still put in the horizontal pieces of steel, you still put in the vertical, in this case they have like a truss steel vertical right here, so that the curtain wall system is attached to it. And you can actually see the attachments. If you look at every vertical frame, there's an attachment. So that's how it's hanging off the structure. So the one thing to really consider with your curtain walls is you still have to have that structure behind it. Always. Always over this. Just go see the skylight's kind of the same idea. Oftentimes when you look at the skylight, maybe go next time you go to a mall, you look at a big skylight and you'll see a steel frame just like this under the skylight. And the skylight's sitting on that steel frame often. Not always, depends how big the skylight is, but once it gets big, it will have that situation.
There's painted open web steel joists.
Yeah, so there's your open web steel joists up there and your metal deck. They've done, instead of doing large beams, they've done big trusses, basically. That's all this is, it's a big grand space. But you know, if this was comparable to your building, you would have beams going across from column to column, and then your joists going that way. Okay, so let's go down this exit. Something what's called sprinkler protected glazing. So these sprinkler heads spray water onto the glass, and they cool the glass so the glass doesn't break, basically. When this building was built, it was a little bit easier to do this. It's a little bit harder now, but it can still be done. So if you have like if you have that situation, you can use it. It's just a little bit more consideration to make nowadays. But it's a nice way to get it. And as well, actually, you can buy glass now. I'll show you some of this later on, but you can get fire-rated glass. That's why you put doors on your bathroom. Sometimes. But you can actually get a glass now. It's a little bit yellow tinge. It's a ceramic. And it actually can give you like a 2-hour fire rate. And there's no sprinklers required, so it's actually fire rate. It's pretty awesome. I'll show you guys. This is that pipe system I was talking about. This pipe here is a span pipe. So you need to find it exit stairs because it's a protected space. It's got the fire rate around it. And the firefighter pump that puts the hoses on here. So maybe older buildings at schools and stuff, you'd see hose cabinets on the wall with the hose. And at some point you realize, what's that? Because the fire can be right there. If there's a protected space, if you're not the stair, come attach the hose and then go and the fire. So that Siamese connection I showed you outside in the other building, that's what pumps water into the system. That's why the truck has to be so close to the front door, that Siamese connection, so they can pump water into the system. And the firefighters come up with a well that has a fire, attach the hose, and it's got space, juice board. They say space, but just stuck on it. It's a good idea. Here's your nosing that's required. Oh yeah, this is the spot that doesn't need code right here. That's what started getting flagged up concrete stairs. So the space is too big. So now these railings are attached to the side. There's concrete stairs. So that this rail right here can get down lower. It's crazy, little details like that. But the building inspector would come on site and they would literally say, if this was a brand new building, they'd say, rip it out right here. That's what would happen. And if you multiply that against every stair in this building, and you're not going to job anymore. That's some big money. Big money. The video on exit, that stair was covered in it. There's another one we didn't go to. It has the same concept where you go down the stairs, and you end up in the basement, and it's just a big, long corridor that takes you to the exterior from the basement. But it's the same kind of concept as that one right there. And they use it as a storage room, which is really bad. I haven't been down there in a couple of years, so at some point I'm going to push pause. How the grip drops into that metal and all that kind of stuff. There's your SSG system. Okay, so they've just decided they want a cap here and they want no cap here. Okay, so that's if you wanted to use this system, I think it's the Courtnage. I can't remember. I can show you. I can't remember which one.
1600 or 75?
No, it's like a slim line or something like that.
Oh.
It's on the second page of products. Very last one is the SSG one. So it's really just design choice where you want. Across the street there, you see the solid plate panels. So that's the spounder panel. So on the outside, they do the plate instead of metal or whatever. On the inside, instead of doing this, just an aluminum gray, they decided to put a wood panel on there. Heating, so again, curtain walls require heat, so they put it in the floor in this case. So there's ducts under the slab here, and the heat comes out of that register right there. Lyndsay was just saying she was talking to one of the architects that worked on this building, and these are some of the dumb arguments you have with trades sometimes. Is the sprinkler people? So these are the sprinkler lines right here, sprinkler the building. They didn't want to curve the pipes. They wanted to come in and just straight pipes straight across. You have to put them down. And so the architects are like, go to there. You got to curve your pipes. So these are the types of little details that.
Actually, it was a technologist.
Well, yeah, previous technology.
Expensive now.
They're the last people to do it. We're doing all those fine details. It's a little things like that. Pay attention. This is the canopy where they took a different approach. So instead of hanging the canopy from the structure on the inside, they just made it a freestanding element. So it's got its own columns on the outside. Now you have no thermal bridge to put it into. Really smart idea. Now, there will be a gap between.
Hey, Lyndsay.
How are you?
Good.
Timothy?
Yeah.
Yeah.
There's a gap up here, but you just splash over that gap, right? And the water's going through there. So it's a much more environmentally friendly design. Drainage on this canopy.
Oh, there it is.
Here, come this side. Here's the drain pipe from the canopy. So again, like, realities you have to deal with right there. And so, is it nice? I don't know. Doesn't bother me, but you would pick this location with your mechanical consultant, and then he might consider the technology to grab this off with a steel. Push it up. You'll see it. They could have done more. And this is in this building. So instead of doing a fire spray, they did what's called intumescent paint. So this is actually a paint of all the steel here that if fire hits it, it'll actually expand out and build a coating around a nice thick coating around the steel. So it's called intumescent paint. So they've done that everywhere here. It's very expensive to do, but it's on the metal deck, it's on all the steel structure, and that's how they go up there 2 hours. It's kind of interesting. Because that fire spray looked pretty ugly, right? So, it was worth it, this building. So, the other thing I want to show you, we're going to look at the curtain walls. We'll go down here. So, again, like a whole bunch of glass. Actually, look at the skylight up here. See the baseball heater up there? There's even heat being delivered around the skylight because everyone's going to get all foggy and stuff. But down here, when we go look at that glass, see the what is that? 1, 2, 3, 4, 5 round columns there? Look really close to the back side. And they're actually fake. So they're using the have vents coming out facing the glass. It's a very clever idea to come up with that. I can assure you that it's a technology system. If we ever tell you to chamfer a corner, this is a chamfer right there. Square enough, or just getting rid of the 90-degree angle on the concrete because it breaks off, right? It breaks over time. So by doing that, it'll last much longer, look much better. And of course, they actually have forklifts that they driving down here and stuff like that. People pushing carts, so then they put protection on here as well. So constantly down your back corridors on your commercial rates, you get retail with the back corridor. These always go in every corner. And it's something that has to be $100. This is a scope of work of new drawings for buildings this size. You could be talking like well over $10,000. It's from the this is that. This is like 40 protections. Yep. There you go. Here's what we're trying to do. The fire rate from the gas station over here. Obviously, that one. Some way to do in the fire if they open the door there for the fire ships. I've never seen it out actually. Do you remember?
No. I can't remember.
Maybe 2005-ish. Anyway, this is one of the this is probably one of the last stairs that got built that has that big gap. I think underneath. Nowadays it's rather touch the side because the gap where you have a lot of those too big. You can see it. a baby gets thrown into that stall. There's so many babies on campus. Because this is an example of where the main floor came out. Sorry, when the main floor came out, grade was higher than the main floor at this door right here. So then somebody had to come up with a solution. What are they going to do? So they built a little retaining wall for the roof, and then they put a drain there. You know, look, there's a drain right there. That's how they dealt with having the floor on the inside lower than the grade on the outside. So, you know, somebody had to come to that conclusion that that was going to happen. They just figured out a solution to deal with it. I think they've oversized these things. I think they should have been half the size, personally.
Yeah.
In the brick, okay, so at every window they put the control joints in. You know, this is also a very clever way to get windows into a basement, right? Cut the grate out and step the retaining walls back with planters, basically. Very smart. You know, this is an exit stair right there that they put glass on. That glass is too close to this glass right here, okay? Because again, there'd be a fire rating around that stair. These windows right here, the punch windows, are in a different fire compartment, basically. So the windows are too close. So if we went inside and looked at those windows right there, the first structure windows, those four, the sprinkler heads on them. So they sprinkler protected that glazing to get away with that. Otherwise, you'd have to have a solid wall there. You wouldn't get away with the windows. So they just found a solution to deal with it. Okay. So
Yeah.
The only thing I have left, if anybody is interested, I have a bunch of samples of things. And nice cozy home for them for sure. That's an EIFS system. I would recommend don't get into this. This is not considered a really high quality system, but it is used a lot. There's no doubt about it. Actually, at the bottom of that wall that you're looking at where it's all damaged, underneath the damage is this stuff, so that they get insulation, but it gives you that look on the outside like it's still a foundation. That's pretty cool stuff. So I'll leave that here if anybody wants to see it.
Wave.
There you go. Have at her if you want to look at.
What do you like? I've been with honey contract